Lesson 1.4, we're going to continue talking about different exponent laws or rules or whatever. And again, guys, the purpose of these is to get you to be able to simplify problems. But the only way we're going to get good at it and be able to know which rules to use is just by practicing. So I'm still encouraging you guys, put yourself out there, try. Don't worry about is it right or is it wrong. I mean, yeah, you want it to be right, but I want you to do what you think is right. Watch the videos, ask for help. I promise I'll help you guys, but I need right now for you to just put yourself out there. Now, the first part of today's lesson is on the rule of 1 and the rule of 0. Good news, I think is good news, is that they're really easy. The problem is a lot of times when things are really easy, we think we're doing them wrong. So make sure you're paying close attention here and don't overthink it. Any number or variable, because that variable, remember, represents a number, raised to a power of 1 equals itself. That's the number 1 there. So basically, if you have x to the first power, that's just x. 6 to the first power is just 6. Don't overthink it. Rule of 0. Now this one tends to trick people up a little bit. Any number or variable, again the symbol that represents an unknown number, raised to a power of 0 equals 1. And that seems maybe kind of weird to us because we want to think that if it's raised to the 0 power, it's 0. And I'm going to explain why it's 0 here in a second. But anything like this x raised to a 0 power equals the number 1. 6 to the 0 power equals the number 1. And this is going to come from some patterning here. So both of these two, rule of 1 and rule of 0, come from some patterning. So let's look at these patterns. 2 to the 4th equals 16. Remember that's 2 times 2 times 2 times 2. 1, 2, 3, 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 2 to the second power is 4. 2 times 2 is 4. Okay? So let's say if I'm putting some numbers in here for a pattern, what does 2 to the 3rd equal? Well, 2 times 2 is 4. Times 2 is 8. If I go 2 to the 1st here, what is that going to equal? Well, that just means there's 1, 2, and according to our rule of 1, any number raised to a power of 1 equals itself. Okay, so now I want you to look here. And notice here we're going down one exponent. When we go down one exponent, what do we do to 16 to get 8? Not subtract 8, but we actually could think of it as dividing by 2. It's subtracting 8 too, but we want to think of it in terms of multiplying and dividing. What do you do to 8 to get 4? Well, you divide by 2. We're going down an exponent here from 2 to exponents to 1. What happens when we divide by 2 again? 4 divided by 2 is 2. So that's how this 2 to the 0 equals 1. We're going down one exponent. If we follow this pattern and we divide by 2, so notice 2 to the first power equals 2. Anything to the first power is itself. Anything to the 0 power is equal to 1. Why? Because we keep dividing by 2. And you actually could continue this. Nope, that's not right. Two to the negative 1. Well, if you divide by 2 again, you get 1 divided by 2. So remember our negative exponents that we did the other day. That's how it keeps working. All right, so let's look at this example. 5 to the 4th power is 625. Again, that's 5 times 5 times 5 times 5. 5 times 5 is 25 times 5. Well, that's to the 3rd power here, right? If we just have 3 5s, 5 times 5 is 25 times 5 equals 125, I believe. And then 125 times 5 is 625. And then we have 5 to the 1st right here, which anything to the 1st power is 5. How does that work? Well, again, notice this time not dividing by 2, but if we go down one exponent from 5 to the 4th, 5 to the 3rd, we divide by 5. Might be easier to see as we get a little lower here. 25 divided by 5 is just 5. 5 to the 1st power is 5. Divide by 5 again. Well, 5 divided by 5 is 1. And there should be no surprises over here. If we keep following these patterns and you guys put up with my sloppiness, I apologize. That's what happens when I start going fast. Ten to the fourth, 10 to the third, 10 to the second, 10 to the first, 10 to the 0. 10 to the third is 10 times 10, which is 100, times another 10, which is 1,000. And 10 to the first should just be 10. And guess what? We're going down by a power of 10, so we're dividing by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. So examples of the rule of 1 and rule of 0 basically are this. If you take any number, raise it to the first power, it equals itself. Even if that number is negative, if you raise it to the first power, it equals itself. Even if you use a variable that represents an unknown number, it equals itself. Rule of 0 says that anything you want raised to the 0 power equals 1. And it's because of this patterning here. If I take -5 to the 0 power, it equals 1. So any number raised to the 0 power is 1. And really, guys, these are just memorizing. Okay, and there's not really any work you can do, but if you can memorize these, even if you don't quite understand them, trust me. And these really can help us simplify some exponential problems.